Welcome to Talkin Science. We've got a jam-packed show for you today. New space shuttles, discoveries in Antarctica and on Jupiter, plus a neutron star likely got devoured last week. Brad's standing by, so let's get into it.
With Dr. Brad Tucker and Matt Miller, this is Talkin Science on Trekzone.
Well, Brad's here. Brad, happy Tuesday.
Yes, another Tuesday, another week, and scarily, it's almost September. It was one of those, I got an email yesterday about planning Christmas parties. I'm like, shut up.
No.
Just stop it. Stop it.
No. I don't know where the year has gone. It's been absolutely crazy.
Yeah, it's space and astronomy. It's just, it's been crazy this year, and it's only getting busier and busier.
How was Space Week last week?
Yeah, Science Week was great. It was there was heaps of events, and it was really fun. So, I was between Cairns and Townsville and Victoria and Canberra and Sydney, lots of events. And it was really great because I think Science Week is getting bigger and bigger every year. And that just shows kind of how it's growing in Australia specifically, all the things that are happening and people wanting to know and also being involved. And that's always a great thing. There is a Space Week in October, so I'll have to think of something crazy for that as well.
Well, before we get there, Sierra Nevada's come up with a design for a cargo shuttle, which I think we've seen it before.
We have. So the Dream Tracer has been around. So this is kind of really essentially, you would think it's a space shuttle if you see it. But it's a miniaturized, so I think it's about a third or half the size, I think it's in between that, of the space shuttle. But instead of needing people, it's completely this robotic glider. So it's a really big step up on the technology, even though it's kind of a throwback to a 1980s design.
It just proves that design was so revolutionary and so good, really, doesn't it?
It is. I think we failed to realize that, the space shuttle had, 127 different flights with all the different space shuttles, and it was a really successful thing. It kind of started to build up space the way we have it today, with assembling the space station and the Hubble Space Telescope and all sorts of things, and then the equivalent of the Soyuz. Those were the workhorses and still kind of have been. And so what Sierra Nevada has done is said, hey, we kind of have the mechanics. Let's improve the design and let's use it to take cargo. So it's not intended to take humans to space, but really just to supply the space station specifically. Pretty much it's a space ferry. That is the equivalent of what it is.
And it can carry 12,000 pounds of food, water, science experiments and other cargo. How does that compare to what we've been using at the moment, Dragon, I believe it is? Yeah,
so you're talking about it's actually on par with what it can carry in terms of weight. Now, it's not as much as obviously the space shuttle, because the space shuttle was gigantic, but it can carry a lot, and that's because they've kind of trimmed down and reduced a lot of the weight and the excess, right? This thing is not really meant to have its own propulsion or steering. It's really cool because what they're going to do is they'll attach it to, and everyone's going to love this, the new Vulcan Centaur rocket. So this is the new name of the United Launch Alliance. So this is the group between Boeing and Lockheed Martin. They're going to attach it. It will launch into space. Again, similar to the space shuttle. It will be able to glide and dock with the space shuttle, and then it's just going to glide back down robotically and land on the Earth. So it's a really cool thing, which means that, pound for pound, so to speak, it is really an efficient system.
And that should be a lot better. Gliding back to Earth and gliding back to a runway should be a little bit easier to recover than Dragon's capsules.
That's right, because Dragon, it kind of parachutes down, lands in the ocean. Soyuz parachutes down and lands in Kazakhstan. But here, they can land it on the runway, and because of the flexibility, they can land it on lots of different runways, right? So they don't need a very long runway. So it is smaller than the space shuttle, so they don't need the huge runway that the space shuttle needed, which pretty much had 3 options of landing sites for the space shuttle. Whereas here, you can imagine if something goes wrong or they need to get back down in a hurry for whatever reason, there's lots of different places this thing can land, and it's a space glider. It's a space ferry glider, and it's really cool. And it's not surprising that NASA has also given the nod for Sierra Nevada and the Dream Chaser to really start ferrying cargo into space because of, the elegance and simplicity. It's kind of one of these diamond or car commercials, but it's for a space shuttle, essentially.
Get exclusive access to podcasts and behind-the-scenes info by becoming a member on Patreon today. Supporting Australia's unofficial home of Star Trek gets even better with membership starting at just $1 per month. Jump over to patreon.com/TrekZone.org.au.
Well, something else that's cool is what Juno's discovered about Jupiter. The latest thing we've learned about Jupiter. Its core isn't as big as we thought.
Yeah, so the inside of Jupiter is quite interesting. So first, for the long time, people would always assume that, hey, you could just fly through Jupiter, essentially. Well, that's not true. There is a fairly large core inside, and it's something not quite half the size of the planet, but it's really weird. And so when you look inside and underneath the clouds of Jupiter, you actually see there's what we call lots of metals. So these are not just pure metals like iron and nickel, but heavier elements, so heavier than, say, carbon and nitrogen and oxygen, that make up the inside of Jupiter. But it's kind of messed up, for lack of a better word. It's this really weird distribution. It's kind of flung all over the place. And so since it's been discovered like this, they've been trying to figure out what is the source of this hecticness. And it turns out it might have been Jupiter got a big smash billions and billions of years ago by something quite large.
Something 10 times more massive than the Earth and almost as massive as Uranus, it seems.
Yeah, it's kind of on par to something like Neptune, right, in terms of this. So something quite big. They went through lots of different options. Could it have been formed differently? Could it have, done this and that? And nothing really fit. And then they said, well, what happens if something smashes into it? Because everything loves a good collision in space. And they said, hey, something about 10 times the size of the Earth, if it smashes into Jupiter early on in its formation, early on when it's just becoming a big planet, could this have triggered the inside of Jupiter to form the way it did? And it appears the answer is yes. Jupiter is actually quite complex. This is why Juno is what's sent to study Jupiter. We always talk of it as a failed star, something that didn't turn on its nuclear fusion to become bigger, or it never reached to become big enough to actually reach that point. But it has lots of moons. It's quite magnetically active, so it has this huge magnetic field. So Jupiter is fairly different from even Saturn and Neptune and Uranus. And so maybe it is that this early collision caused Jupiter to become quite unique. And collisions are actually quite common, we think now, or at least more common than we thought, right? We think something like Mars crashed into the Earth to form the moon. We know in 1994 there was a comet that smashed into Jupiter. We actually saw it, or saw parts of it, and it created a hole 12,000 kilometers wide, which is literally the size of the Earth. So maybe the early solar system was quite turbulent and quite chaotic, and this helped form the way the planets did.
Well, Juno's mission's been extended to 2022, so we should be expecting some more revelations ahead.
That's right. I mean, I think we're just scratching the surface, and it keeps turning out really great science. And it's really funny, right? Everyone, when Juno was launched, kind of was weird because why are we going to study Jupiter? Don't we know a lot of it? But Jupiter really just always was forgotten, right? We studied other things, and it's like, oh yeah, well, we haven't really looked at Jupiter. We had Voyager fly by it, and that was it. Even Cassini was dedicated long before looking at Saturn, and it's starting to see how Jupiter is quite unique and how it formed, because Jupiter's formation and how Jupiter came to be really impacts the rest of the solar system more probably than any other planet. And so it's integral to not only just Jupiter, but the entire solar system. So I think, as you're right, lots more things to be found.
New content is being added all the time to Trekzone's YouTube channel, Talking Science with Dr. Brad Tucker on Tuesdays, Trekzone Live on Thursdays, and a Trekzone Conversation on Saturdays. Don't miss a moment. Subscribe and ring the bell to get fresh public releases.
Well, let's go galactic now. And it seems that some gravitational waves might have been picked up last week as a neutron star got devoured.
Yeah, so on top of Science Week last week, we also had this. Now, where I come in is, so one of the things that there's heaps of people doing, and I'm on, I think, 5 different teams because there's lots of different telescopes, is when we get a gravitational wave event. So this is something massive happening in space that causes a ripple of gravity through the universe. So if you imagine the universe is this giant sheet and you change it, you throw a ball in or you pluck it, this will create a ripple in space. And we've been detecting gravitational waves now for almost 3 years. But one of the things that we haven't seen is what we call a black hole swallowing a neutron star. So we've seen black holes colliding. We actually see them all the time now. It's so 2017. Saw also in 2017 2 neutron stars colliding. So on 2017, August 14th, 2017, not that I remember that date, we saw 2 neutron stars colliding. But it appears we now have seen a black hole swallowing a neutron star. So kind of the third thing that we think would produce massive gravitational waves. And of course, just as the 2 neutron stars colliding happened during Science Week, a black hole swallowing a neutron star happened during Science Week. It's really comical because it was on par almost to 2 years. And what we think is that we think there could be what we call an electromagnetic counterpart, i.e. it could also produce visual light in some sort of band that we can actually see this event.
And I believe that SkyMapper is trying to find the visual evidence of this.
Exactly. So when the 2 neutron stars collided 2 years ago, what happened was the gravitational wave happened, and kind of cool, a gamma ray burst event happened. So we've wondered what gamma ray bursts are, or a type of gamma ray burst, and they went off within milliseconds. And everyone's like, hey, let's look at this thing. It just so might be coincidence. And sure enough, we saw what we call the optical counterpart. We saw the actual explosion from the 2 neutron stars. They look very different from every sort of explosion. So now when we think things other than 2 black holes colliding go off because they probably don't produce any light, we trigger lots of telescopes all around the world. So pretty much every telescope around the world that has a big field of view, that has a big patch of sky you can look at, jumps into action. So a telescope I'm involved with in Chile jumped into action. In fact, I was on the telescope on Wednesday doing this exact same thing, except we also had clouds. And then SkyMapper jumped into the action. So pretty much everyone became a global alert saying, hey, let's pinpoint. The problem is, even though we kind of know relatively where the gravitational wave event happens, and we can pinpoint when it happened about 900 million years ago, you can imagine something spreading over a distance for 900 million years ends up being a large patch of sky you have to find. So it is like finding a needle in a stack of needles that's been swallowed up by a black hole. You don't really...
And we're all the same color.
But sometimes they might even have color, right? So you don't even know what you're looking for. And so it becomes this really big... It is a treasure hunt. It is a modern-day scientific treasure hunt in the truest sense of the word. And so in the midst of Science Week, we're coordinating telescopes all around the world, SkyMapper, Chile, Hawaii, to look for this thing. It appears we did not find the counterpart. Most people now, given it's been about a week, nothing conclusive has been found there. None of that, hey, this is clearly it. We've seen things, we've seen asteroids, we've seen other supernova, but nothing that is not explained by some other phenomenon that we already know. And so it appears that we just didn't see this one. And so that means, hey, maybe this doesn't produce light, or maybe we just missed it. So, the hunt will be back on.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Get the wrap-up on our Facebook page. Keep in the loop on Twitter and relive Trek episodes on Instagram. Just search for Trekzone.
Well, let's come back to Earth because astronomers in Antarctica have melted 1,000 pounds of snow and discovered that there might be a supernova buried down there.
Yeah, so one of the cool things that's been happening is we know when a supernova goes off, it produces lots of elements. And this kind of showers into space. So one of the cool things that happened a few years ago is someone drilled into the seabed and they took a deep core and then they looked at the elements present and they found lots of elements that weren't naturally occurring on Earth. So now when a star explodes, it breaks up all of the protons and all of the neutrons, and it actually ends up creating what we call exotic elements, things that kind of naturally can occur themselves. So a group of scientists said, all right, well, let's just take 1,000 kilos of snow, melt it, and do the same thing. And sure enough, what they found was unique signatures of elements that cannot be created here on Earth. They had to be created in something massive that we think is a supernova. So it really appears that our Earth was bombarded by supernova stuff a couple million years ago, anywhere between 2 and maybe 20 million years ago, and this would have rained down kind of radioactive elements on the Earth.
I just love how in the article that you sent me, that's described as the recent cosmic past.
It is recent, millions of years is quite recent. But this is actually quite interesting, right? We do know stars explode. We know stars explode in the relative neighborhood, but we haven't seen one visually or really nearby in about 400 years. But we also know that these supernova produce radioactive stuff and elements. So in fact, if our Earth was showered by supernova stuff millions of years ago, when things were definitely alive on this planet, it would have had some impact on the way life either evolved or formed or lived, quite interestingly, right? Because if it's found in Antarctica and found in the oceans, it means it definitely hit the Earth and would have landed all over the ground. So it's kind of a really interesting thing to think about how exploding stars are quite integral or quite impact the way life evolved on our planet.
So do you think it would have been, if there were people around back then, it would have been something like a meteorite shower or something like that, something that actually hits the Earth? Or
yeah. So it'd been quite interesting because if it's, and this is one of the big questions, is how close do you have to be to get enough of these radioactive elements to land on the Earth? So, we know from 400 years ago when the supernova went off that Galileo saw it and people saw it visually. Did it necessarily rain down a lot of stuff? Probably not. So this means this is probably something relatively close, even potentially closer than the previous ones, that was close enough to have enough of these elements actually hit the Earth, right? Because if you imagine an explosion and then showering out into space, the further away you are, the less likely you're going to get impacted by this. So to get enough that it's actually measurable in snow, to get enough that is actually measurable in the oceans, means that it was relatively close. So it would have been a very bright event, and things, people, humans, whatever, would have really noticed it. And how it actually came to be, we probably wouldn't have seen the stuff, but like today with our radioactive detectors, every alarm probably would have been going off that we've been showered kind of a little bit of like nuclear fallout almost with the planet. So it's a really interesting concept about how it all impacts stuff. And then when we think about how supernova explode impact the lives on other planets, it's really interesting to see how it's integral to both the formation and the evolution of life on a planetary system.
Fantastic, Brad. Well, what a fascinating dive into science and space news this week. Jam-packed show. Really appreciate you coming on it. We're looking forward to chatting to you next week.
Take it easy.